Let's talk about metamorphic rocks. Here are our learning goals. Explain the difference between regional and local metamorphism. Explain what a parent rock is. Describe and be able to identify the types of rocks that are seen with increasing degrees of metamorphism: slate, phyllite, schist, and gneiss. Explain how any rock can become any other type of rock through the rock cycle. Metamorphic rocks form when a parent rock is subjected to heat and pressure. When that happens, new minerals will form, and the parent rock looks different. There's two types of metamorphism. The first one we're going to talk about is regional. That's when mountain building occurs, and of course we get that when we get convergent tectonic plates. When we have two continental plates converge on each other, then they put enormous pressures on the rocks where the two plates come together. This type of metamorphism can cover large distances, many miles. The second type of metamorphism is local. That's when magma moves into an area and it basically cooks the rocks that it comes in contact with. Here's an example of local metamorphism. This is the Purcell Sill that's present in Glacier National Park. Here is some basalt that was deposited in a crack in this parent rock when magma forced its way into the crack. If you look carefully, you see right along the basalt, this rock looks whitish, but if you move out a little bit, it's its normal gray color. When this magma moved in, it heated this rock up tremendously and caused metamorphism, but only over a distance of a few feet, maybe 10, 20 feet, and that's it. So local metamorphism occurs over small distances. Regional metamorphism can cover areas that are miles wide. There are two basic types of metamorphic rocks. The first type we're going to talk about are non-foliated metamorphic rocks. Foliated means layered. So these are metamorphic rocks that don't have layers. The two common ones that we're going to talk about, one of them is called quartzite. In quartzite, the parent rock is quartz sandstone. If we take quartz sandstone, which is basically beach sand that's been cemented together, and subject that to great heat and pressure, then we get quartzite. In quartzite, the quartz crystals grow together and merge, and you get a very durable hard rock. In this area, quartzite makes up the tops of the ridges of the Blue Ridge Mountains. Another type of non-foliated metamorphic rock is marble. If we take limestone and subject it to heat and pressure, the calcite that makes up the limestone will recrystallize and form marble. Now remember, calcite reacts with acid, so marble sculptures and marble buildings tend to dissolve over time due to the effects of acid rain. Now the other basic type of metamorphic rocks are foliated metamorphic rocks. Foliated metamorphic rocks have layers, and we name them according to the intensity of the metamorphic change. In other words, the more heat and pressure that they're subjected to, the greater the change that will occur. So, increasing heat and pressure cause increasing change in the rocks. Slate has the least amount of metamorphic change. Gneiss has the most. And phyllite and schist fall in between. In that order: slate, phyllite, schist, and gneiss. It's important to remember that. So let's talk about slate. The parent rock for slate is shale. Shale is a sedimentary rock. When shale is subjected to heat and pressure, it forms slate and develops very distinctive layers which are easily split. And that makes slate a convenient building material for roofs. Some roofs are made out of slate. patio coverings, and other building materials. Another type of foliated metamorphic rock is phyllite. If we take slate and subject it to even more heat and pressure, tiny flakes of mica will develop and make the phyllite look shiny. So if you look at it in the light, this is shiny, slate is dull. If we increase the heat and pressure, then phyllite will become schist. Schist can form from lots of different types of rock, but if we take phyllite and we subject it to increasing heat and pressure, then the little mica flakes that we saw that made this shiny will grow and become fairly large. And schist looks scaly or flaky. If we take schist and subject it to even more heat and pressure, almost to the point where it melts, then we'll get gneiss. Gneiss oftentimes has these wavy bands in it, these wavy layers. And if we look at it, more new types of minerals will be present, because one of the things that causes minerals to form is metamorphism. So the minerals that are in the schist will change and become new minerals in the gneiss as we increase the heat and pressure. Now, the last thing we're going to talk about is the rock cycle. There's almost none of the original crust of the earth left on the earth because rocks are constantly being recycled. Any type of rock can be transformed into any other type of rock given time and the right conditions. Okay, so let's look at this example. Here's some granite, an igneous rock. Weathering will break it into fragments. Those fragments can form sandstone, a sedimentary rock. This sedimentary rock, if we subject it to metamorphism, heat and pressure, we can create a metamorphic rock. And if we continue to increase the heat and pressure, we can actually melt this metamorphic rock back into magma, and the magma can become granite again. So that's one possible outcome for granite. Here's a simple diagram that shows how any rock can become any other kind of rock. Suppose we take that gneiss that we've been talking about and we melt it. Well, it can become an igneous rock. If we weather it into fragments, then it can become a sedimentary rock. If we take a sedimentary rock and we subject it to heat and pressure, it can become a metamorphic rock, and that can break down due to weathering and become another sedimentary rock. An igneous rock can be broken down by weathering to produce a sedimentary rock. The sedimentary rock can be subjected to heat and pressure and become. So any type of rock can be transformed into any other type of rock given the right conditions.